So step one is for every state, find the equivalent states to it. The ones you can go to by following sequence of empties. So let's label the states. Okay, let's find what's the equivalent to 1. Always the state itself is equivalent to itself, right? Because by using no tape I can go there. I'm already there. So 1, what else? 2, what else? 3, because I can go empty, empty, I can go to 3. How can you go to 4? Oh yeah, you can go 1, 2, then you follow this empty, 4. Okay, state 2. What's equivalent to it? Besides 2, of course. 2, 3, 4. Okay, 3. 3. And 4, 4. Right? Okay. Now, after you calculate this, you are ready to build the deterministic automaton as follows. The states, the states of the deterministic one will be labeled by subsets of the set 1, 2, 3, 4. So here the labels are individual numbers. You have 1, 2, 3, and 4. Here the labels will be subsets of that set. Okay. The starting state, the label of it will be the equivalent set of the starting state here. Okay. What's the starting state here? 1. What's the equivalent set of it? 1, 2, 3, 4. That's the label of this guy. So you always start like that. Okay, then, what's the alphabet here? A and B. So out of every state, you must have just one A arc and just one B arc coming out. So you go to a new state. Now, to determine what should this be labeled as, just start going from each, since they're all equivalent, just start checking the original graph. From 1 with an A, where do you go? Okay. 2 with an A, 3 with an A, 4 with an A. And every destination is in the label set. Okay, from 1 with an A over there, where can you go? To 4. 4. Huh? Right. So put it here. 2 with an A.
1 with an A can go to 3 also.
Yeah, I missed that. You're a good eye. Okay, yeah. 3 also. 1 with an A. You can go to 4 and 3.
2 with an A.
2 with an A.
2.
2. 3 with an A. Oh. Now, you get the problem here, right? Okay, I made a big mistake. Step 1, before you do this, I skipped one step. If you have labels of arcs that are not individual symbols, you've got to convert them to individual symbols. That should be the first step. So the first step should have been this one. How do you convert an arc labeled with a substring, right? Huh? Yeah, you introduce new states. In this case, I have 2 symbols, I need 1 new state. If I have 3 symbols, I need 2 new states to go 1 by 1 by 1. Okay. So A, B. Actually, what you do is you say, okay, with an A, go to this new state, and then with a B, this is the same as AB arc. So you introduce new states, you break down the substrings. In which case I need another label, 5. That's why you do this step before you do this. I have 1 more state now. Huh?
What will be the final state then?
What?
What will be the final state then?
3.
3. I cannot make this a final state. Because the original said, if you're here with an AB you go and you're a final. Not with an A. If I make this final, I'm saying, oh, with just an A, you can be final. But originally you said with an AB you go there. Not with an A, with an AB you're final. So this new state you introduce cannot be final. Okay? It should not be final. But now I have another label. So when I'm doing that, this will not change this though in this case, will it? Right? 5, but I have the equivalent set of 5 is 5. Right? Okay, so here, 1, 2, 3, 4, where are we? From 3 with an A, where can you go? 5, that's it? B, yeah, 5. From 4 with an A. Actually, 4 doesn't go anywhere, does it? Anymore. Okay, nothing. Okay, so the label is 2, 3, 4, 5. This is distinct from that. If this label was the same as that, this would be a self-loop instead of a new state. It's the same state. So this is different. Okay. Now repeat with a B. Okay, 1 with a B. Nothing. There's no B. Right? There's no B. 2 with a B. Nothing. 3 with a B. 4. 3 with a B is a 4. This goes that way. 4 with a B. Nothing. 4, that's a new state.
5.
It's, what?
Oh no.
What?
No. There's no
Okay,
5.
that's the only label in there. Okay, so 4. Okay, continue. With an A here, with a B here. Now, do you worry about this being an infinite loop? Will I ever terminate? You're guaranteed this process will terminate, right? Because the labels are subsets of 1, 2, 3, 4. I have a finite number of labels, finite number of subsets. There is a maximum number of possible states. Okay? Like 2 to the 4th, to the 5th. Hopefully there will not be that many. Right? Okay, so here with an A, where do you go?
2, 5.
Okay, let's do one by one. 4, nothing. 3, 5.
2.
From 2
Two.
with an A.
2.
2. Oh, something else now. If from state I, like 3 or whatever, you go to state J with an A, then you can also go to everything equivalent to J. If you go to a state, you can go to its whole equivalent set, can't you? Because once you are in state J, you can follow empty, 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 and you are there also. So another thing to remember is once you went somewhere, right, look up here and put down the whole equivalent set of it. Once you go to it, you go to everybody in that set. Did we do that? Will that change anything here?
2, 3,
2, 3, 4. Yeah, we have 2, 3, 4. Right? It will not change anything. 4, 4. Okay. So I went to 5. I went to 2. Right? But once you went to 2, you know you can also go here.
2, 3, 4.
So put 3, 4. And I lost track where I was. Did I do 3? 3
Yeah,
with
we are
an
done
I
with
did
that.
2. Yeah, I did 2 with an
5, we don't.
Now I want to do 5. Nothing.
Okay.
So 2, 3, 4, 5, it's this guy. It's itself. So self-loop. Okay, with a B. 4 with a B. Nothing. 3 with a B. 4. And the whole equivalence of it, which is just 4. And 3 with a B. 2 with a B. Nothing. 5 with a B.
3.
3. And the whole equivalence of it, which is only 3. 3, 4, that's a new state. Okay, from 4 with an A.
Nothing.
Nothing.
So 4.
What? No, with an A, from 4 with an A, you cannot go to 4. I don't have the self. With an E, you can stay to 4. From 4 with an A, you go to nothing. There's no state, no label. Okay. So what's the label of this state? The empty set. We said the labels are subsets, right? The labels are members of the power set of the label set. So this is the empty set. 4 with an A, empty set. That's the label. Okay. 4 with a B, empty set. Right. Now, you see, a state labeled empty set, this is corresponds to the dead-end state. From the empty set, where can you go with an A? Well, if you don't have a base, you cannot go anywhere. So you go back to the empty set. So this is the dead-end state. With A, with B, you stay there. Okay, let's do the 4-3 with an A. 4 with an A, nothing. 3 with an A, 5. Well, that's a new state. Equivalence of 5, 5. With a B. 4, nothing. 3 with a B. Nothing. 4, yeah. Right. And the equivalence of 4, 4. But I have this state. So with a B, I go there. Okay, everybody's closed now. A, B, A, B, A, B, except this guy, right? Okay, 5 with an A. Nothing. So where do I go?
5 doesn't
What?
5 with a B.
5 with an A, where do I go?
And
The empty set, I go to this guy, the dead end. Okay, 5 with a B. You
3.
go to 3,
Finals.
and the equivalent of 3
3.
is 3, so just 3. Do I have this? I don't have that. So it's a new state. Right? Okay, 3 with an A. To 5. Right? So I go back here. 3 with a B. To 4. And the equivalence of 4 is just 4. So I go to down there.
Still.
The process terminated.
To mark the final states.
Now, I don't need the labels anymore, but before you erase the labels, who are the final states? I need to know that.
Although that
Okay.
include the three
Correct.
states.
Every state, who was the final state here? 3. Or it could be more than 1. It could be like 3 and 2. Then everything that contains in the label set 3 or 2, any of those final states is final. So in this case, anything that contains 3 is a final. So let's see. This guy is final. No.
3, 4 final states.
This is final. No. No. Final. I forgot that. What is this?
That's 5.
Oh, I erased it. Okay. Okay, final. Okay. Supposedly this, if you did it right, it will turn out this is the deterministic. This is deterministic by construction. Say A, B, subsets. You know. For example, the empty string, is he accepted here? Sure, because you're there, this is final. Is the empty string accepted here? Sure. Go here, here, it's good. All right, let's take another one. How about AB? He's accepted here. How about AB over here? Sure. A, B. You go empty, empty, then A, B is good. Okay. It will be equivalent to the original one if you apply The advantage is very easy to program this, not so easy to program that. Okay. So any questions? One example is enough, right? Or what is the code here? Is it still doing it? I don't know. The tapes usually are 2 hours long, right? But how do you change from LP, SP, this? You know what I'm talking about?